Today we are traveling to Monticello, Illinois to meet critical zone scientist Dr. Jenny Druin and her colleague Julian Boucher. Dr. Druin operates a one-of-a-kind laboratory located on the banks of the Sangamon River. Let's go inside and take a tour.
Hi!
Hi!
Welcome to the Riverlab!
Thank you!
Absolutely. I'm Jenny Druin. I'm an associate professor at the University of Illinois in the Department of Earth Science and Environmental Change. And we have a special guest this week.
Hi, I'm Julian Boucher. I'm a CNRS researcher in France at the Institut Physique du Globe in Paris.
So you're sitting inside of a river lab. We have the sign to prove it. And this is a one-of-a-kind facility in the continent. It's developed in France, and there's several of them in operation across the country in France, but this is the only one so far to be operating here. And so essentially the philosophy of the entire facility is rather than bring the river samples back to the lab, we bring the lab to the river.
Stepping inside the Riverlab, I hear the pumping and humming of scientific equipment working around the clock to sample water from the Sangamon River. The lab itself is divided into two spaces. I follow Dr. Druin to a room filled with a complicated tangle of tubes and pipes.
And then back here is the more physical part of the river lab, where we're actually pumping water from the river through the facility and back to the river again in real time. And so it's a little bit messy and it's a little bit loud, but basically the river water is coming in. It's flowing through this system. This is sort of the heart of the whole facility, where we filter a tiny bit of the water. It comes through this valve and into this tank. This is the river itself. Temperature, conductivity, pH, turbidity, dissolved oxygen getting measured all the time around the clock. And then the water comes out of the tank through this little loop-de-loo and back to the river again.
We step back into the analytical part of Riverlab to take a closer look at the chemical makeup of the river. Here, Dr. Druin is measuring the major ions that are present in a small sample of water. By comparing this data to the amount of water flowing through the river over time, we find that each tiny drop of water tells a story.
And here we are back in the analytical lab. And so here what you're looking at is what we call an ion chromatography system. It's a dual column, which means that we can measure both the major anions and the major cations together. The system runs at about a 30-minute interval. So every 30 minutes we get a new measurement of all of the major ion composition in the river. Here you can actually, if you zoom in, you can see that little drip of water. That's our tiny, tiny, tiny little sip of the river that we're measuring around the clock in real time. And when that turns into data, it looks like this. So what you're seeing now is an example of sodium concentrations in the last week. Every 30 minutes, a measurement being made. You can see a little storm that happens, so the concentrations dropped. You can see that the flow has been decreasing and now the concentrations are rising. And we watch this all the time around the clock.
As you can see, so much is being learned by this little lab by the river. Stick around to find out more.